In this video, we will be talking about why e to the power of pi I plus 1 is equal to 0, along with its applications. To start, we'll need a basic understanding of trigonometry and complex numbers, both of which we'll talk about in this video. Let's get started with complex numbers. A complex number is a number of the form a plus bi, where a and b are real numbers. But what is this I? I is the square root of -1. So in other words, a complex number is any number of the form a plus b times the square root of -1. But it's cleaner to write a plus bi. For example, this is a complex number, 3 plus 4i. Note that the numbers also can be negative. For example, 3 minus 4i. Or they can also be irrational, like root 3 plus pi I. Those are all complex numbers. However, this is not a complex number, 1 plus ii. Because note that in the earlier definition, we stated that a and b must be real. This I is not real. This can be further simplified to 1 plus I squared, which is equal to 0. Okay, so that's complex numbers. But what is trigonometry? It all lies on the unit circle. The circle centered at the origin with the radius of 1. Okay, so let's just imagine that we label every single point on this unit circle with a number between 0 and 360 degrees. For example, this point would be labeled 0 degrees. This point would be labeled about 60 degrees. This point would be labeled 90 degrees, and so on. Note that 0 degrees is also 360 degrees. It's also negative 360 degrees. It's all positive or negative multiples, integer multiples of 360 degrees. Now, how does this relate to this pi? To start, we'll need to introduce something called a radian. It's a simple conversion between a degree and a radian. Pi radians is equal to 180 degrees. Note that when you're expressing something in terms of radians, you do not have a degree sign. But when you're expressing something in terms of degrees, you do. So it's pi radians is equal to 180 degrees. So now let's relabel every single point on the circumference of the unit circle using pi's, radians, instead of degrees. So this would still be 0. This would be pi over 3. This would be pi over 4 at 45 degrees. This would be pi over 2, and so on. Note that 0 degrees is also 0 radians is also 2 pi radians, which is also 4 pi radians, which is also negative 2 pi radians, and so on. So there are infinitely many ways to express each of these degrees. But how does this relate to trigonometry? That's the thing. So you probably heard, what's the cosine of 7 pi over 4, for example? Okay, so to start finding that cosine, you'll need to look on this circle and find where 7 pi over 4 lies. In this case, it'll lie, so that's pi over 2. That's pi. This point is 3 pi over 2. And so 7 pi over 4 is going to be about here. To see that, we know that this point is also 8 pi over 4, and this point is 6 pi over 4. So 7 pi over 4 is the middle. Okay, so now we need to see what's the cosine of that. It's pretty simple. It's just the x-coordinate of that point. Okay, so the x-coordinate of that point is going to be this length right here. That's the x-coordinate. Note that the x-coordinate can also be negative. if it were cosine of pi over here. The cosine of pi is going to be equal to -1 because that's the x-coordinate of this point. Let's just compute cosine of 7 pi over 4. So since it's 7 pi over 4, it's a 45, 45, 90 right triangle. And we know that it's unit circle, so that's 1. So then that is √2/2. And so that's the x-coordinate. Cosine of 7 pi over 4 is equal to √2/2. So that's cosine. But what about the sine? The sine is the y-coordinate. So the sine of 7 pi over 4 is going to be equal to the y-coordinate, which is just -√2/2. Because this point 7 pi over 4 on the unit circle, its coordinates are √2/2, comma, -√2/2. But the sine of pi, for example, would be 0 because it's 0 coordinates above the x-axis. In other words, its y-coordinate is 0. Okay, so that's trigonometry. There's also other definitions like tangent, which is simply tan of theta is equal to sine of theta over cosine of theta. But tangent isn't very relevant here. Okay. So now that we know sine and cosine and what complex numbers are, let's move on to Euler's formula. The proof of Euler's formula is beyond the scope of this video. Okay, so Euler's formula states that e to the power of I theta is equal to cosine of theta plus I sine of theta. But what is this e? How does this even make sense? To start to understand this, you'll need a sense of what exponential forms are. So I'll just clear this definition of complex numbers, so then I can write up there. And if you want to reference this, go back to the trigonometry part to see what cosine and sine mean. Okay, so basically you have a complex number, but there's another form to write in a complex number. For example, you have the number a plus bi. And that number can also be rewritten as r times e to the I theta. That's interesting. But how does this really work? Well, let's do some definitions. R is going to be equal to the square root of a squared plus b squared. Okay, what about theta? Theta is going to be the degree. What do I mean by that? Or the radian? Because let's just say you plot a plus bi on the complex plane. So then maybe it's over here somewhere. Or this is the origin. Then theta is going to be this degree. Okay, so it's basically similar to the trigonometry degrees. Like that's, for example, pi over 3. That's pi over 4. It's the same thing, except, for example, this point is also pi over 4. It doesn't have to be on the unit circle. It just, if it were dilated by some factor about the origin, then it would stay the same degree. So theta is that value. So it's over here. Okay, so now that you know that, let's try to see how we can apply this into here. So if we plug that in, we'll get a plus bi is equal to r times cosine of theta plus I sine of theta. Expanding this and matching coefficients gives a is equal to r cosine theta and b is equal to r sine theta. Okay, so now a is equal to r cosine theta and b is equal to r sine theta. If you look, this actually makes a lot of sense because, for example, a is going to be the x coordinate and cosine theta is going to be the x coordinate, and you're multiplying it by the dilation factor. So this actually makes a lot of sense. Okay, now that we know that, let's try to see why e to the I pi is equal to -1. This is actually a direct application of Euler's formula. E to the I pi is equal to cosine of pi plus I sine of pi. Okay, so cosine of pi, so if we graph that, it's going to be this point over here. So the cosine, the x coordinate is going to be -1, and sine of pi, the y coordinate, is going to be 0, which is equal to -1. So that's why e to the power of pi I is equal to -1. That's it for this video. If you like this video, please subscribe and share with others. Thank you.